In this example, I want to calculate the cell potential of the electrolytic cell according to the reaction shown below. 2I minus plus Al 3 plus gives Al plus I2. So iodine is -1, that's the oxidation number. Aluminium is +3. Here aluminium is 0 and iodine is 0 as well. So as you see here, iodine is going from -1 to 0, so we have oxidation. And here +3 goes to 0, so it means that we have reduction. So if I want to write the half reaction, that's going to be equal to Al. And on the other side, you have 2I minus gives you I2 plus 2E minus. So here we have reduction. Here we have oxidation. Where reduction happens, we call it cathode. And where oxidation happens, we call it anode. So now we want to find out the cell potential. The standard cell potential is delta E. We put the degree sign here to show it's standard. It means that at 25 degrees. So equals to standard reduction potential in cathode minus the standard reduction potential in anode. So it is going to be, in cathode we need to find these two numbers. We need to use the table. If we use the table, we're going to find out the reduction potential for aluminium is -1.66 volts. And for iodine is I2 plus 2E, because that's standard reduction potential. So in the table you have just the reduction. This is 0.54 volts. So then what I can do, cathode we have aluminium, so that's going to be -1.66 minus ER of anode, which is going to be 0.54. That's going to give me -1.66 minus 0.14. It's going to be -2.2 volts. That's going to be the cell potential for this reaction.